Okay, question number 22. Let us switch on the timer. White light is emitted from a hot filament. Hot filament, okay. Light passes through hydrogen gas at lower pressure. When you mean about lower pressure, what do you say? Pressure lower means the temperature is also lower because pressure is proportional to temperature, okay. Then passing through a diffraction grating on a screen, a pattern of lines against a background appears on the screen. So there is a background, there is a lines. Okay, what is the appearance of the lines and background on the screen? Okay, many of my students have written this is black with white background. No. Okay, so you have to understand the question clearly here. Right, so it says you are having a white light is emitted from a hot filament, and then it is coming through an enclosure which has a low temperature, and then from here light is coming out from here. As a result of it, when you say low temperature, what happens? The molecules or atoms, electrons which are present over here are already at this level over here, right, at the ground level. So when this light comes over here, then what happens? The electrons get excited to the higher energy levels. Across 1 minute, okay. Okay, so electrons get excited to the higher energy levels. So in order that electrons get excited, some amount of energy is being absorbed over here. So what kind of spectrum are you getting? You are getting an absorption spectrum. When you say absorption spectrum, that means the wavelengths. Let us say, for example, the white light is giving you something like, let us say, 1000 different wavelengths over here. 1000 different wavelengths, of which, let us say, 8 wavelengths are being captured by this one. Why do you say it's captured? The reason is because the 8 wavelengths will have a corresponding energy also. Why energy? Because you know E is equal to hc by lambda, right? So therefore, one wavelength is being captured. That means that corresponding energy is being absorbed by the electron, and the electron move to the higher excited state. It could be the first state, it could be second state, third state, and everything. It's all in the ground state. And when it moves, the rest of the wavelengths, what does it do? It just emits out, just comes out of it, right? So therefore, there is an absorption taking place, and after some time only these rays will come out. So by the time this rays, the light that comes out over here, it has already come out over here, and you are now capturing it on a diffraction grating. And when you see it on diffraction grating, you see a colored pattern, and you also see the absence of these lines as the black lines. So therefore, what is the correct option here? It should be D over here. Now what happens in emission spectra? In emission spectra, it doesn't happen like this, right? You have, this is already, some of the electrons are already present in the excited states, and they start jumping to the ground state. As a result of it, photons are being emitted, which means what? You get a black background and you get a colored pattern over there, colored lines over there, right? That is your emission spectra. Okay, let us move on to the next question. 20